All right, so in this lesson, we will basically identify minor and major arcs, and then we're going to use something called the arc addition postulate to calculate the or unknown central angles and arc measures. All right, so let's start off with this circle. We have a circle. An arc is like a curved or a part of the circle, right? So AB, arc AB is this part right here. Arc AC would be from here to here. Arc CB would be from here to here. Not too difficult. All right. The only thing you gotta really make sure you understand is that if it says AB, it's talking about the shortest distance from A to B. So AB. But if if it says something like ACB, it means you start at A, you go through C, and you go all the way to B. So this is conventionally would be arc AB. This all the way around would be arc ACB. You could also say arc BCA. So rather than give you a definition of arc, it's easier just showing you what an arc is. Central angle. So this 60 degrees right here is a central angle to this arc. If you notice, the central angle starts from the center and opens up to create the arc. Central angle starts in the middle, opens up to become or to create this arc, so to speak. Now, if you notice also, the central angle and the arc have the same measure. So if we go the other way around, if this is 60 degrees, this would have to be 300 degrees because a whole circle is 360 degrees. That means this arc ACB or BCA also equals 300 degrees. Okay? Or equals 3. Now, let's go through a few simple examples. So right here, we are going to calculate the measures of various arcs and central angles. So let's start with our central angle. So you see how this arc AC is 120 degrees? That means this central angle right here is 120 degrees. So that means angle COA. COA is 120 degrees. Now, if we look at this, this is a diameter. A to B is a diameter. Diameter cuts perfectly through, halfway through a circle, so this would be 180 degrees. So this portion would be 180 minus this 120 would be 60 degrees. So COB, so angle COB is 60 degrees. Okay, we're good there. And let's look at AOB, angle AOB. Let's make AOB, because even if you go this way, it'll be the same. AOB, remember, if this was half and this was 180 out of 360, that means this is also 180, because this is a semicircle. This is half a circle. Those are the central angles. Let's do the arcs. Okay, so let's just do a couple of them. We don't do all. We know that arc AC was 120 degrees. But we also know that if the central angle COB is 60 degrees, we know that arc CB is also 60 degrees. And lastly, we know that A to B, either way, AB, so arc AB is 180 degrees. Easy enough. All right, let's look at these last two. So instead of writing it all out here, let me just show you a couple. I know it's to the side, but it's fine. So remember that EB, if it looks like it, let's just assume it is. EB looks like a diameter, so it cuts halfway. 150 plus 30, 180. Makes sense. So let's not forget that these are like CRB and ERA are vertical angles. So that's 50 degrees. This is 50 degrees. Now, we can't do the same with the 30 degrees because this is clearly an obtuse and this is clearly an acute. But we know that this is 180, so 180 minus 50 is 130 degrees. So this is 130 degrees. This is different. All right. So let's just name a couple of them just for sake of doing so. Make sure you understand, I guess. Not really for sake. So let's do this though. DA. Let's do some arcs first. So DA, remember if we say DA, arc DA, it's the shortest distance, which is here to here. 30 and 50 would be 80 degrees. Easy. Let's do the opposite of that. Instead of going D to A this way, let's go to DCA like that. So arc DCA. All right, DCA. So 150. Well, let's do this. 100, 130, 230 plus 50 is 280 just to get to A. Yeah, that's all we're trying to get to, right? Yes. So that's 280 plus 50 is 300 and wait, what am I doing wrong? All right, let's try this again. Sorry about that. All right, we're going over here. D, C, A. This is why I should draw it, right? This is why I should draw it. So 150 plus 130 is 280 degrees. Probably should have written that down, but you're fine. You're smart kids. Let's do some central angles. So let's do CRE. So angle CRE. CRE would be 130 degrees. Now let's try one of these. Let's do this. You see how it says DA? Well, that would be angle DRA. DRA would be from here to here, so that's 80 degrees. So this and this are like central angle opens up to this arc. Let's try DCA. So DCA, woof, this would be angle DRA, but this would be like the obtuse version, I guess. And once again, if we add them all together, we get 280 degrees. I think you get the point here. You don't really, I mean, this is 90 degrees, right? And you can get it, so I'm not worried about this. Let's try the next page. All right, so there are these things called major and minor arcs. So the minor ones, you see how this circle is comprised of two arcs. This arc here and this arc here. So arc CB this way and arc CB this way. This is the minor arc because this is a small one. And the major arc is the large one. Okay, once again, minor arc, smaller, major arc, larger. Minor arc, major arc. When you put these together, because I think about them as in pairs, and they equal 360. 360. 360. Even in a semicircle, there is no minor or major because one's not larger or smaller. It's just called semicircle because they're both 180 degrees. All right, so find the measure of each minor and major arc. So let's do our minor arc. It looks like it's right here. So remember, this is the central angle is 40 degrees. That means this is 40 degrees. So the minor arc is DF is 40 degrees. Now the major arc would be this way around. And DGF. Arc DGF. You remember, you can't just put DF because then it's going to be the shortest distance. That's what's assumed. So we can just take this away from 360. 320 degrees. 320 degrees. So let's do minor over here. So minor would be the smaller one, which is 110 degrees. Is right here. Remember that? 110 degrees. And this would be our major one. So, oh, let's not forget the name. The name of the minor is LN, arc LN. And the major one would be LN, but the other way, so LMN, which is 360 minus 110, 250 degrees. Easy enough. All right, so arc and angle addition postulate. We sort of used this already, but you get it. So it says arc GHE. So arc GHE. GHE is 40 plus 80. This whole thing here is 120 degrees. Is 40 degrees plus 80 degrees equals 120 degrees. Not difficult. Arc GEF. GEF. So GEF. So GEF is going to be 40 degrees plus 80 degrees plus 110 degrees. And you add them up, you get that. Like, you get the point. Arc GFE. Arc GFE. So arc GFE. All right, so we don't know this part right here, so we can get that though. So we just take our 360 and we take away 40. We get 320. So we can take away that one. Let's take away 80. So that'll give you, so this goes away, to 40. We take away the 110. We get 130 degrees. 130 degrees plus, remember this 110 right here, and you get 240 degrees. Not too difficult. I'll show you one last thing, right? So we're looking for the measure of x. Now remember this right here, if it looks like a diameter in this activity, then let's just assume it's a diameter. So here to here total, this semicircle, is 180 degrees. And we know if we put this and this together, we would get the total 180 degrees. So x plus 138 plus x plus 48 should give me 180 degrees. So we don't even need those parentheses. So I'm going to make them go away, or just drop them. I get 2x plus, that's going to be 6. 4 plus 3 is 7. 7 plus 1 is 8. And then we get a 1 equals 180. And from this point, you know how to solve for x. You subtract 186, 2x equals negative 6, divided by 2, x equals negative 3. All right, not too bad. Thank you.